What if one tiny man-made island in the North Sea could change the future of Europe's energy forever? A place with no houses, no people, just cables, converters, and pure potential. Belgium's Princess Elisabeth Island is not your average infrastructure project. It's bold, ambitious, and it might just be the most important piece in Europe's green energy puzzle. But can it really power an entire continent? Or is it just a futuristic dream? Subscribe now, because only those who stay until the end will know the truth. Why do we need this island? Europe is racing against time to transform its energy system, and Belgium's energy island could become a key player. For years, the continent has relied on fossil fuels and external energy suppliers, creating both environmental and geopolitical vulnerabilities. The war in Ukraine brutally exposed this dependency, with gas prices spiking and supply chains faltering. In response, the European Union doubled down on its commitment to green energy. But building a sustainable grid across dozens of countries isn't easy. It needs infrastructure that connects, balances, and stabilizes. That's where the Princess Elisabeth Island enters the picture. Planned for completion by 2030, this artificial island in the Belgian North Sea isn't about tourism or real estate. It's a transformer hub, a massive offshore connection point linking wind farms, national grids, and interconnectors to other countries like Denmark, the UK, and Germany. Its purpose is simple but powerful. Gather electricity from offshore wind farms, convert it, and distribute it efficiently throughout Europe. Today's grid can't handle the upcoming surge in renewable energy alone. Offshore wind is booming, but without a coordinated system to channel this power inland, much of it risks being wasted. The energy island acts as a central socket, a multi-plug extension cord for the continent. It's also climate-proof, built to withstand North Sea storms and tides, and designed to evolve as technologies improve. In essence, the island isn't just a Belgian project, it's a European one. It symbolizes the future of cross-border energy cooperation and sets a precedent for other coastal nations to follow. And if it succeeds, it could drastically cut emissions, boost energy independence, and even lower costs for millions of European households. What is the energy island? The Princess Elisabeth Island is a world first. Positioned around 45 kilometers off the Belgian coast, it's set to become Europe's first artificial energy island, specifically designed not for tourism, luxury, or expansion, but purely for power. Unlike other artificial islands in places like Dubai, this one isn't about buildings or beaches. It's about electrons. Covering roughly 6 hectares, the island will serve as a critical offshore energy hub, essentially a large-scale transformer platform in the middle of the North Sea. Think of it as a floating power switchboard. Its job is to collect electricity from nearby offshore wind farms, convert and stabilize it, and then distribute it to the mainland and neighboring countries. Engineered to handle extreme marine conditions, the Princess Elisabeth Island will host high-voltage substations, converter stations, and crucial interconnectors. It will become the heart of Belgium's offshore wind zone, linking together multiple wind parks, some of which will be built up to 60 kilometers away. The goal? To efficiently handle up to 3.5 gigawatts of offshore wind power. Importantly, there will be no residential or commercial development on the island. No homes, no hotels, just high-tech infrastructure, sealed in reinforced concrete and engineered to withstand decades of salt, storms, and waves. The project represents a major step in Europe's renewable ambitions, not just for Belgium, but as part of an interconnected continental strategy to achieve net zero emissions by 2050. This island isn't just a technical marvel, it's a symbol of how serious Europe has become about transforming its energy backbone. Technology. How does the energy island actually work? At first glance, the Princess Elisabeth Island may seem like just another offshore platform. But beneath the surface, literally and figuratively, this floating hub hides a cutting-edge network of cables, converters, and connectors that could reshape Europe's energy landscape. Here's how it works. Electricity is harvested from several offshore wind farms scattered across the North Sea. These turbines generate alternating current, AC. But that's not suitable for long-distance transmission. That's where the island steps in. Acting as a massive converter station, the energy island transforms AC into high-voltage direct current, HVDC. which is far more efficient for sending electricity across long underwater distances. Once converted, the electricity is routed via undersea cables toward Belgium's mainland, where it's reconverted back to AC and fed into the national grid. But that's just the beginning. The real game changer is that the Princess Elisabeth Island will also be connected to other European power networks, including Denmark, the UK, and Germany. These interconnectors will allow energy to flow across borders, depending on demand and production. This is not just energy transmission, it's energy orchestration. In times of surplus, Belgium can export. In times of shortage, it can import. It creates a flexible, decentralized energy network across the continent. Technically, the island must withstand massive saltwater corrosion, wave impacts, and mechanical stress from the cables. Every component, from the HVDC converters to the switchgear and transformer bays, is housed inside protective modules, engineered for offshore longevity. This system isn't just a marvel of modern energy design, it's a template for future offshore energy hubs across Europe, and possibly the world. Who funds the energy island? Mega projects like the Princess Elisabeth Island don't just need engineering, they need money, a lot of it. With a total cost hovering around 2 billion euros, the funding puzzle is as complex as the technology behind it. The key player behind this monumental investment is Elia, Belgium's national transmission system operator. Elia is responsible not just for building the island, but for integrating it into the larger European energy framework. The company sees this island as a long-term infrastructure investment, one that could make Belgium a central hub in the continent's renewable power distribution. But Elia is not alone. The project is being developed in strong alignment with the European Union's Green Deal, which aims to make Europe the first climate-neutral continent by 2050. The island is expected to receive funding and policy support through EU-level mechanisms, including the Connecting Europe Facility, CEF, and the 10E regulation, which prioritize transnational energy infrastructure. Moreover, the Princess Elisabeth Island is a core element of the broader North Sea Power Hub vision, an ambitious plan to link up Northern Europe's offshore wind capacity. Countries like Denmark, the Netherlands, and Germany are watching closely, and discussions are ongoing about joint funding models for shared grid infrastructure. So, while the island is physically Belgian, its financing and future are inherently European. It's a symbol not just of innovation, but of shared responsibility in powering tomorrow. Criticism and challenges. While the Princess Elisabeth Energy Island stands as a symbol of progress, it is not without controversy. The first major concern involves the environmental impact. Building an artificial island in the North Sea inevitably disturbs fragile marine ecosystems. Environmental groups have raised alarms about sediment disruption, underwater noise pollution during construction, and the long-term presence of large-scale energy infrastructure in what was once untouched seabed. Though environmental impact assessments are in progress, questions remain. Can large-scale green energy truly be green if it threatens biodiversity? Secondly, construction delays are a looming threat. The North Sea is known for its harsh weather conditions, strong winds, rough seas, and unpredictable storms. Combined with the need for extensive regulatory approvals, especially for cross-border grid connections, the timeline for completion could stretch significantly. Previous offshore projects in Europe have shown that even small delays in permitting can lead to years-long setbacks. Technologically, the island must act as a multinational converter hub, using high-voltage direct current (HVDC) to integrate power from various offshore wind farms and distribute it efficiently to Belgium, the UK, Germany, and Denmark. Coordinating this across different regulatory systems and infrastructure standards is a massive challenge, both technically and diplomatically. Critics also argue that centralized offshore megaprojects draw attention and funding away from more immediate, local energy solutions, such as rooftop solar, community grids, or land-based wind. For some, the island represents a top-down solution in a world increasingly demanding grassroots sustainability. Still, despite the criticisms, the project moves forward, powered by ambition, backed by policy, but shadowed by uncertainty. What does it mean for Europe? The Princess Elisabeth Island isn't just a Belgian project, it's a European statement. Positioned in the heart of the North Sea and connected to multiple countries, the artificial energy island is poised to become a strategic cornerstone in the EU's plan for energy independence. As geopolitical tensions highlight the fragility of fossil fuel imports, the island serves as a bold move toward generating, storing, and distributing renewable power within European borders. It will act as a hub for energy import and export, seamlessly connecting offshore wind farms to national grids across Western Europe. With high-voltage direct current (HVDC) lines to Denmark, the UK, and potentially Germany, the island transforms Belgium from a transit country into a central player in Europe's green energy network. This level of coordination is unprecedented and reflects the broader vision of the European Energy Union, a policy framework aimed at integrating member states into a single, resilient, and sustainable energy market. Beyond infrastructure, the island carries symbolic weight. It demonstrates what's possible when public funding, EU policy, and technical innovation align. Already, other coastal nations, like the Netherlands and Denmark, are exploring similar models, seeing Belgium's lead as a prototype for multinational collaboration on energy. If successful, the energy island won't just power homes. It will power a new era of sovereignty, sustainability, and interdependence in Europe. A true energy landmark, floating in the sea, yet deeply rooted in the continent's future. Will it power Europe? No, at least not on its own. But Belgium's Princess Elisabeth Island is a game-changer in Europe's transition toward clean energy. While the island cannot supply electricity for the entire continent, its strategic location and advanced technology make it a vital piece in the puzzle. Its real power lies in its ability to connect, balance, and store energy across borders. By acting as a central hub for offshore wind power, it helps manage volatility, reduce transmission losses, and create a resilient energy grid that spans beyond national lines. More than a power station, it's a platform for innovation and collaboration, setting a precedent for how countries can co-develop infrastructure instead of isolating their efforts. In a time of rising energy nationalism and climate urgency, the energy island symbolizes a different path: integration, not isolation. It won't solve the EU's energy crisis alone, but it shows what's possible when bold ideas are backed by shared commitment. The future of energy isn't just about power, it's about partnership. Will this artificial island truly reshape Europe's energy future? Or will it remain just another expensive showcase? The next chapter unfolds with Denmark's own energy island project. Don't miss it. Subscribe for more cutting-edge infrastructure stories, like the video if you learned something new, and let us know in the comments. Do you believe in the vision?